Hello, this is Jonathan Johnson here again. Today we're working on activity 3-3, simplifying IPv6 addresses. So this activity, there's not really no steps to do in the Windows Server on this specific activity. We're just going to be our objective is going to be to transcribe IPv6 addresses using rules for simplification. Description is in this activity, you use the rules discussed earlier to simplify IP addresses by removing leading zeros and multiple zero groups. You also convert simplified addresses to their original state. So I'm gonna I got a thing I found on here online I can show you. Give you a little thing about these. So say we have, let's find one. I think I'm on the wrong. Actually, we can make this easy. We can go. All right. Say we got this right here, 1075 colon, then 4 zeros, then another colon, then 4 zeros, then you got another colon, 4 zeros, colon, 4 zeros, colon, you got 4 more zeros, then you got another colon, alright? Then you got 3 zeros and a 5, then another colon, then you got 0, 6, 6, 0, 0, then you got another colon, then you got 300C, another colon, and then you got 422D. Alright? Now, that's the full IPv6 address. Now to simplify that, to make it so you don't, oh well, I got 5 groups of zeros, so you got 1, 2, 3, 4, 5 of them, So you'll put in FF06 semicolon D5, and that right there, that's the simplified. This is a simplified address for this IPv6 address. This one's the full address, and this one right here is a simplified address of it. Now, let's see. Now we're going to talk about notation usage. So, IPv6 addresses can be written with CIDR notation for subnetting and address. You no longer need subnet masks for this task in IPv6. So, for example, the following address we're going to put in represents a 48-bit network. Let's get out of it. Alright. So, this one would be a 48-bit network. So, 1075 semicolon 5 semicolon alright, semicolon AB12 semicolon /48, and that /48 represents that it's 48-bit network. So we need, remember, you always have the two networks too that you cannot use, the host network and the broadcast. Not the host. What am I thinking? What's the other? I can't remember the other one. One of them's the broadcast network. You cannot use those. You got to have, I think, it's 2, might be 3 that are required to not be used. They got to stay open. I know one is the broadcast. All right, so that right there represents a network with a 48-bit network address. That's what the /48 is. We're gonna put this in. Represents the address. All right. Now, because IPv6 notation uses colons as separators, you have new standards when using for NNC. You have a UNC pass. For UNC pass, all colons become hyphens, and IPv6 literal.net is appended to the address. For example, connecting to the user share on a 208 semicolon B semicolon 2F36 semicolon 41 semicolon 25 AB results in the folder UNC path. That's a shorter path, like when you cut things down, instead of typing in this whole big old long thing. IPv6 address types, we got a IPv6 addresses fall into the following types: link local addresses, unique local addresses, global addresses, multicast addresses, and special addresses. In this one, we're going to talk about link local addresses. Hosts use this type of address for communication with other hosts on the same network segment because all link local addresses have the same network prefix. They cannot be routed between networks. All IPv6 interfaces have a link local address. That means IPv6 interfaces can have multiple addresses. In contrast, IPv4 addresses typically have only one address. So link local addresses are made up of the following. So a link local address will be made up of the first 10 bits are always, so here, let's do this. Alright. The first, man, my typing is off. The first 10 bits are always going to be binary, so they're always going to be 1111 space 1110 space 10. That's what the first 10 bits are always going to be on a link local address, because it's their local address. You know, like, hey, I got Wi-Fi at my house. I gotta go from my laptop or my phone or game system or whatever they have nowadays that connects to Wi-Fi or whatever, which is pretty much everything. Here soon, your shoes will be connecting to it. So, so that's one of the things that always will be on there for a link local address. The next 54 bits are always going to be 0. So the link local address in CIDR notation. In CIDR notation, it is FE80 semicolon slash 64, and that's not motation, it's notation. That's another one. And the third one that will third thing that you will always have in a link local address is the remaining 64 bits represent the interface ID, or they represent the host addresses on the network. Alright, so those are three things that always will be making it made in the makeup of a link local address. Remember, you'd put /54 /64. That's the CIDR notation. When you have, like, it'd be so on semicolon 9. You know, I'm just typing stuff in. Then you go /54. So there's 54 bits in that network. It's a 54-bit network. That slash is what that CIDR notation kicks in the gear when you break down the 54 bits of the local network. Not exclusive to link local addresses, zone IDs are necessary when using link local addresses. Zone IDs are used when a computer has multiple network adapters. To distinguish among the multiple networks, each IPv6 address is appended with a %sign and a numeric zone ID. Following is an example of link local address using zone IDs. Alright, so when it's saying they're appended to it, it means you'd go, remember, like when we were working in the Cisco classes, you would do assignments on there, and they say that, okay, well, fast Ethernet 0/1 needs to go to the router. So you'd go into the router, first you go into the fast Ethernet, you type it in, hey, I need this thing to direct connect or Wi-Fi connect to this router right here. It'd be a direct connect, of course, with a crossover. And then It'd go in, you set it up to append directly to go to that. Well, this thing is the same thing. You have to go in, and you have to go into the, like if you want to connect your laptop to it, sometimes you might have to go in, type in the IP address of the router, append an IP address from the computer to the router to append it to get to that network manually. I don't know if I explained that thoroughly well enough, but that's how I usually do that stuff. Let's see what else in here I can go over. Simplifying IPv6 addresses. I think I pretty much talked about simplifying them. I mean, this is the long version of it, and this is shortened version of it. So I got a little page here on the internet I found out about shortening and simplifying and compressing IPv6 addresses. Just a little how-to that the book didn't talk about in much. So IPv6 addresses are 128-bit binary numbers which are represented in hexadecimal format. Right there. Well, not to check the. Which are too lengthy and difficult to handle in our day-to-day life. Consider a situation where you need to ping an IPv6 address. This long address. Check the network connectivity. Think about the pain in typing all the IPv6 addresses hexadecimal characters in any short shell prompt. Just think about pinging and typing that in every time. Oh my gosh. I know you could copy and paste, yeah, but most, still, it's still a pain about when you can just type digit ping, shortened it. Somehow we need to shorten and simplify this IPv6 address to use it with more ease. We can further simplify, shorten, and compress using the following methods. Omit the leading zeros for simplifying and shortening lengthy IP addresses. Then, for example, in IPv6, this address, the leading zeros are marked as, so see all these right here? Leading 0, leading 0, leading 0, leading 0, leading 0, leading. So this one right here would be 2001 DB8 B1A. That's what it would be when you take out those zeros, because you don't need them. They're just taking up space. It's like when you have 329, usually people a lot of times will write 039, or when you have 39, in the hundreds they go 039 because it's 39 out of 100. So you just take out all those zeros, that leading zeros. Now if it doesn't lead with a zero, you keep that entire number in there. Next one could be compress consecutive hexadecimal fields of zeros using double colon. So that's double colon right here in place of series of consecutive hexadecimal zeros. So for example, we have 2001 right here. We have this IPv6 address. We have a series of 3 consecutive fields of hexadecimal zeros. So see right here, we'd put a semicolon right there, 2 of them. We would just double it before the 1A. So we just put right there, okay, add another semicolon right before the 1 right there. Note that compressing and shortening a series of consecutive fields of hexadecimal zeros is an IPv6 address is possible only once you compress a series of consecutive fields of hexadecimal zeros twice in an IPv6 address. So that's pretty much all I have for you today on this activity of simplifying IPv6 addresses. If you have any questions, shoot me an email. I've looked into this pretty well. We've been doing this for 3 years now in classes. I hope you learned something on this activity. Thank you, and see you guys later on. Bye.